Good morning students. So next we are going to discuss about the work done in the adiabatic process. The definitions and the basic concept of this process we have discussed already in the previous video. Now we will derive the expression for the work done in adiabatic process. We know this thing that PV gamma is equal to constant. PV gamma is equal to constant. This is our adiabatic equation. I can write this also, P1 V1 gamma is equal to P2 V2 gamma, because these are constant. Now we know to find the total work done we need to do integration, and we will take limits as 1 and 2. Now P dV I can write, where I have this equation PV gamma is equal to C, then in place of P I can write C upon V raised to power gamma into dV. Now C is my constant term, so I can take this constant term outside. When I will, as you know, if you don't know about the integration, you can see this thing. While doing integration, we write by such way, means after solving integration, we get here power, suppose n power I have, and to solve the integration I will add 1 over here, and the added power I'll keep in the denominator, x n plus 1 divided by n plus 1. This is the method for doing integration. So C is constant terms always we have to keep outside the integration. So when I bring this v raised to power gamma in the numerator, this power will become in negative. So v raised to power minus gamma into dv. C is outside. To solve this integration, I already told you this method, x n plus 1 upon n plus 1. So here also plus 1 I will add in the numerator, and that added power I will keep in the denominator. So v raised to power minus gamma plus 1 divided by minus gamma plus 1. Limits 1 to 2. Now what I'll do, I'll put limits turnwise. Higher limit minus lower limit. So in place of v, I can write v2 raised to power minus gamma plus 1 divided by minus gamma plus 1 minus v1 minus gamma plus 1 divided by minus gamma plus 1. Here I have written v1, that is lower limit. Here I have written v2, that is higher limit. Now I will multiply this constant with both of these terms. So C V2 minus gamma plus 1 divided by minus gamma plus 1 minus C V1, and this term I got. Now just see what I can write. This is C V2 C V1. Already I told you PV gamma is equal to constant. P1 V1 gamma is equal to P2 V2 gamma. So in place of this V2, इस V2 की sorry, in place of this C, in place of C what I can write, PV gamma. ये क्या है मेरे पास कांस्टेंट ही तो है. सो इन प्लेस ऑफ दिस C I can use that equation, that is adiabatic equation, means PV raised to power gamma. So C here PV raised to power gamma into V2 minus gamma plus 1. In place of CV1 again I will write PV gamma V1 लिख सकते हैं इसको, P1 V1 into V1 minus gamma plus 1. Here P2 V2 gamma and V2 minus gamma plus 1. Here P1 V1 gamma into V1 minus gamma plus 1. So P2 V2 raised to power gamma into V2 raised to power minus gamma plus 1. Here again the same term. Now just see this thing. We know when the base is same, we can add the powers. Like just see this thing. V2, we have this power V2 gamma, V2 minus gamma plus 1. When you will add V2 gamma minus gamma plus 1, this gamma will get cancelled out, and it will be only P2 V2. Here also P1 V1 divided by minus gamma plus 1. Afterwards what I have done, I brought this minus as common term, and inside the term will be P1 V1 minus P2 V2 divided by gamma minus 1. So here also I took minus common, here also minus will get cancelled out, and the total amount of work done in adiabatic process we will get P1 V1 minus P2 V2 divided by gamma minus 1. So this is as this gamma is the ratio specific heat at constant pressure to the specific heat at constant volume. In last video also I told you the value for gamma is Cp upon Cv. So this is the required expression for the work done in an adiabatic process.